Hello and welcome to today's webinar focusing on AS9145, Shaping the Future of New Product Introduction within Aerospace and Defence, brought to you by Industry Forum and hosted by Richard Hammond. Richard is our Principal Engineer, specialising in the teaching and training of core tools here at Industry Forum, and without further ado, I'm going to now hand over to him to take you through the webinar.
Hello, and thank you for that, Andy. I'd like to spend a few minutes of your time just introducing you to the newly released AS9145 standard. This standard was released in November 2016 and it covers advanced product quality planning, more often called APQP, and the product part approval process known as PPAP. This standard was authored by the IAQG, which is the International Aerospace Quality Group. It's a group of like-minded companies who are working together to try and deliver more value at all levels of the supply chain. The IAQG membership comprises of significant OEMs and multi-tier organisations within the aviation, space and defence sectors, and the IAQG membership covers Asia, Europe and the USA. The IAQG created a multi-tier and multi-member group to author AS9145, and the standard is issued under the authority of SAE International, which is the issuing body for all AS standards. AS9145 basically does two things for us. The first thing it does is describe the process, and in this instance the process is advanced product quality planning, and the output of that process then is the production part approval process, often called PPAP, and PPAP is one of the many methods that could be utilised to actually give suppliers formal acceptance of their product into the end user and customer. So in real terms then, AS9145 covers the APQP process and product buy-off at the end of that process. The origin of APQP goes back to the automotive sector, and the first real version of this was authored by the Automotive Industry Action Group, or the AIAG, which includes Ford, GM and at the time Chrysler, among others. And the AIAG created a 5-manual set, often called the Blue Books, which cover what were known as the automotive core tools. And the aerospace industry has leaned heavily towards the automotive approach and the frameworks contained within the Blue Books. Looking at an overview of the aerospace APQP standard, then we can see that it has 5 phases, and these phases are mirrors of what was in the automotive version. So we have the planning stage, which leads into product design and development, followed by process design and development, and then we get to the first acid test of the process, which is product and process validation, where we actually validate the design that we've created and the manufacturing process to manufacture the products. And then normally at this stage it's the point where we get formal customer part approval, and then finally APQP moves to the 5th stage, which is the ongoing production, use and post-delivery service of the products. As we can see in the timeline, there's some key product approval process events. So the first one of these is leading off the end of stage 3, which is where we do the production readiness review. And this is the activity where we actually review our manufacturing processes and make a decision, are they fit for purpose? We then achieve first article inspection, which now demonstrates that the manufacturing process will actually produce the product to the required specification. We then go into a production process run, which is an all-up simulation of the production process in real life. And from that, we get information such as right first time and our ability to achieve the customer's rate potential. And then finally, towards the end of step 4, we get the part approval. If we consider then that APQP is a process, then if we follow this process, then the 11 PPAP elements that are required by AS9145 will have been covered. And so I think one of the themes for today is that if we follow the APQP process, pretty well everything we require for PPAP will have been achieved. If we think about how the world might look like without APQP, what we can see here then is that if we look at the curve, we can see that during the development phase, there's relatively few problems being detected. However, if we take the purple traces indicating attempts to ramp up production, then what we can see is two things happening. As we're trying to ramp up production, we're also encountering more and more unresolved concerns. And so we have the nightmare situation here, which is that we're trying to ramp up production plus deal with all of the problems that have arisen. Now, this, if you like, is a blueprint for a situation without a lot of thought going into prior planning for product introduction. It's characterized by low initial resource, no team involvement, and a mentality of waiting for problems to be detected. The results of this is that the project will suffer delays, it will be subject to unmanaged expense, and ultimately customer dissatisfaction. So let's look at the situation with effective APQP. Well, in this situation, what we can see is that the intent of this graphic is showing that up front during the development stage, we've anticipated problems, we've resolved them, and we have solutions for them, so that when we start manufacturing and try and ramp up production, again shown by the purple curve, in this instance we have what's called vertical product launch, which means that all of the upfront planning has been effective, and as a result there's very, very few concerns which are inhibiting the production ramp up. This is characterized by high initial resource, cross-functional team involvement, and problems identified and eliminated as soon as there is a potential to do that. So we've moved into a very proactive way of operating and not reactive. The benefits then are that we get on-time delivery, far better budget control, and we're getting satisfied customers. So what could we categorize the purpose of APQP being? Well, the purpose of this process is to ensure reliable production launch and also smooth implementation of change. The expected benefits align very nicely, and that is that the organization's activities align with the goal of achieving customer satisfaction. We have communication of product quality planning requirements to all interested parties. We're able to direct resources to satisfy the customer. We're able to promote the early identification of required changes. So we are being truly proactive. If we're being proactive, then we're going to avoid late changes. And obviously late changes become progressively more difficult to manage. Ultimately though, we're going to provide a quality product on time at the lowest cost, meeting the customer's required production and delivery rate. So when would we apply AS9145 with its APQP and PPAP? Well, AS95 should be applied to new product development and to products currently in production where changes are planned, and can be applied to final product or selected levels of parts, for example, sub-assemblies. So the requirements can be applied at all tiers of the supply chain, and in fact that's where it's going to be at its most effective, at each tier of the supplier chain, achieving the goals and the benefits of APQP takes variation and waste out of the complete supply chain. Producers and their suppliers are responsible for the flow down of the requirements of this standard. When AS9145 is required, APQP and PPAP shall continue to apply when previously approved products and processes undergo change. So one of the prickly subjects that we run into with advanced product quality planning and PPAP is the question of legacy products. Is the intent to retrospectively apply these controls? Well, the answer is no. However, if there is a significant change to a legacy product, then best practice says that we would manage that change using APQP, and we would use PPAP as the customer's acceptance of the change. For APQP to be effective, we need management commitment, and so without any doubt, the implementation of APQP has to be a top-down activity. So we need the management commitment and support from the beginning of the product development cycle, using multidisciplinary project teams, integrating all of the interested stakeholders and delivering a committed timeline for executing planned activities. Within the management of APQP, without any doubt, one of the key players is going to be the project owner. And so the organisation needs to identify, if you like, an APQP or PPAP champion, and this person is going to be responsible for accomplishing project objectives and ensuring appropriate resources are available. So a lot of time and care needs to be taken into account when we define the role for this individual. We need somebody with the necessary authority and respect to be able to carry this role and this project through. From personal experience, quite often PPAP and APQP starts to unravel if we don't have the right person in this project owner role. We touched on multidisciplinary approaches, and for APQP to be fully effective, then we need to have a multidisciplinary approach. And so when we think about this, it could be people from any interested sector, so design, manufacturing, engineering, quality, production, and other stakeholders. They all should be striving for a common goal, and the mathematics of this is very simple. Both the supply organisation and the customer have a common goal, and that is to get the product into production, because the organisations don't benefit until products being manufactured and sold on to the customer. When we think about project management, then we need a project planning and a project plan, and we need to ensure that not only does the project planning include the technical content of the project, but it also needs to plan in the advanced product quality planning activities. So it needs to define when the activities are going to start, when they're going to finish, and how they're going to be reviewed. And so what we need then is a timeline for the project, and as far as the product quality planning element goes, then APQP gives us that timeline by references activities back to the 5 phases. If we think about APQP then, it's based on the Plan, Do, Check, Act cycle. So the first step is planning, where we're looking at customer inputs, market demands, the voice of the customer, and we're going to roll that up into a specification then that we can pass to the product design team, who are going to be operating stage 2 of APQP. So this team is going to define the product parameters, specifications and characteristics. That data then is passed to the process design and development team, and this team is going to develop the manufacturing processes that will realize the design in real life. We then get to step 4, which is product and process validation, which is a checking activity. And step 4 is really confirming 3 things. The first thing is that the product meets the specification. The second thing is that the manufacturing process can achieve the right quality. And the third thing is that this process can achieve the required rate. It's normally at this step 4 that PPAP's achieved, and then at step 5 we move on then to ongoing production, customer use and post-delivery service. So let's take a few minutes now and look at the 5 phases in a little bit more detail. So if we look at the planning phase then, we have a number of activities. The deliverables then are the outputs from the process in terms of either content for the PPAP file or information that's required to be passed to the next stage of the project. And then finally we have the stage output. So the planning stage then is that the goal of this phase is to capture customer inputs, benchmark data, lessons learned, regulatory requirements, technical specifications, company know-how and strategy into a product concept and a realization plan. This includes identification of high-level technical, quality and cost targets. And so the output from step 1 is that the product concept is finalized and a pre-design is available. If we then move to step 2, which is product design and development, again we have activities, deliverables and output. And so the goal of this phase is to translate the technical quality and cost requirements into a controlled, verified and validated product design. Design validation is achieved using prototype, development or production parts in test environments that can represent the customer's installation and subject the product to extreme conditions required by the contract or regulation. The output of this stage then is the design record and bill of material, design verification and validation plans and the associated results. It's during this phase then that we have created the design records, which is the records of engineering definition and specification. This includes such things as hard copy prints, or it could be electronic digital drawings or electronic digital models. It could even be software or other associated information. This includes records of authorized engineering changes not yet incorporated into the released engineering definition or specification. So when we talk about these authorized engineering changes, we're actually talking about changes initiated by the design team that actually sit between issue levels of the drawings. And so by these controlling these, we're able to ensure that the people developing the process always have the latest information. Hand in hand with the creation of the design specification then, we need to be doing design risk analysis. And so we're looking at the risks associated in achieving the required fit, form, function, durability, service life, reliability, manufacturability, maintainability and cost. And so we're going to do this design risk analysis, and one of the most conventional ways of actually doing this is by use of design FMEAs. And when we consider things like key characteristics, then part of the design FMEA process would be to start anticipating which features of the design are either going to be safety critical, reliability critical, or going to give problems with achieving regulatory compliance. When we think about risk and risk mitigation then, DFMEA may be flagging up the risks, and by matching occurrence against severity, we can get some indication of how we should react to the FMEA process. So anything falling out in the red sector, then it's a high risk and action must be taken. So this would be instances of maybe safety, regulatory or reliability issues. Anything falling out in the yellow zone, well, it's medium risk, action should be taken. So this could be things like form, fit and function, where maybe additional manufacturing time and effort is going to be incurred. And then finally in the green zone we have low risk, and these are more trivial items where if we have the time and it's economic to address, then we need to address them, but our focus should always be in the red zone. One of the key steps at this point then, and this step is bridging design to manufacture, is feasibility. So we actually need to assess the feasibility of the design, and we need to answer questions like, can the design be manufactured, assembled, tested, packaged and delivered in sufficient quantity on schedule? So I think the theme here is that although we may have achieved a product design, it may not actually be feasible to manufacture that product. And so feasibility is the real acid test of actually saying, okay, I understand the specifications, the tolerances, the requirements. They are within the normal area of the supply organization's expertise, and as a result they believe that the product that's being designed can actually be manufactured. So I guess feasibility is a good hold point. If any of the information that's required to make that decision is unavailable, then we really should not be moving to the next step until we've cleared that all away. We then move on to process design and development. So we've received the technical package from the design team. We're now designing a process to actually manufacture the product as it's been designed. So the goal of this phase is to design and develop the production processes needed to produce product that consistently fulfills the technical, quality and cost requirements while operating at the customer demand rate. And again, we have activities, we have some deliverables, many of which will roll up into the PPAP file, and then finally the output is that the production process is defined and deployed, and we have successful completion of the production readiness review. Again, a number of PPAP elements roll out of section 3. So we have the process flow diagram. This diagram is a pictorial representation of each of the manufacturing steps required to create the product and should encompass alternative processes. So it may well be that when we design the process we have 2 alternative fixtures that can be used, and so what we would try and do on the process flow is anticipate that either of those fixtures might be used, and as a result we can show the prime process flow and the alternate process flow using the secondary fixture. The process flow diagram then feeds into the process failure modes and effects analysis, and effectively what the FMEA is doing is taking each step of the process flow and actually analysing the risks inherent in that step. And so again we're looking for risks associated with processes and process results that could have an impact on safety, maybe have an impact on the reliability of the product, and again regulatory compliance. Having mentioned earlier that the design FMEA is going to be a vehicle for identifying key characteristics, then these characteristics are going to port into the process FMEA, and yet even while we're doing the process FMEA we may actually identify process characteristics which we deem key. Both the results of the DFMEA, the process flow and the process FMEA then feed into the control plan, and in simple terms then the control plan is how we control the risks that we've identified in the DFMEA and PFMEA. And again, one of the key things about the control plan is the management of key characteristics. At this stage, we would also start turning our attention to packaging, preservation and labelling. And at this point, we have to be very aware of the customer's requirements. So although AS9145 gives us a baseline standard, when it comes to things like packaging and preservation, including labelling, then we're going to need to refer back to the customer and either gain knowledge of the customer's standard or actually propose to the customer our standard and seek approval from them in the methods that we have suggested are used. So again, stage 3 activity, but already thinking towards shipping the product, labelling the product and preserving it both in-house and in transit to the customer. We've now moved on to step 4, and step 4 is the product and process validation. So it's at this point that we actually apply the acid test as far as our product design and our process design. So the goal of this phase is to validate that the product fulfills the design requirements and the production processes have demonstrated the capability to consistently produce product conforming to the customer requirements at the customer's demand rate. Product validation achieved using product produced from the defined production processes. So if we think about this then, right the way up to the start of section 4 then, or phase 4 of APQP, unless we've had prototype product, then we haven't got product to work with. We're now about to create what's known as the production process run. This production run will create product, and it's this product that we can use then to get the final elements of PPAP in place. So thinking about that then, the production process run is a product and process validation performed on product produced from the processes intended for ongoing serial production. What's this mean in real life? Well, what this means is that we're going to manufacture a number of products through the manufacturing process using production tooling, equipment, people, methods, and so this is a simulation, if you like, of the conditions that the product will be made in real life. Typically, the number of products that needs to be produced or the duration of the production process run is agreed with the customer. One of the keys, though, is that sufficient product shall be produced during the production process runs to determine process capability and capacity and able to confirm product produced fulfills the design requirements. Data that we get from the production process run is right first time, rate, but now we have parts, we can now conduct measurement system analysis. And so as a rule of thumb then, any key characteristics that are identified on the control plan, then we need to do an MSA study on the measuring devices that actually validate the characteristics that are listed in the control plan. The analytical methods and the acceptance criteria used shall conform to the organization's or customer requirements, and obviously when we get unsatisfactory MSA results, we need to refer back to the customer and agree an action plan as to how we resolve that problem. Linking with KCs again then, for any KCs that were listed on the process control plan, then we should run a process capability study. And so what we're going to do here is monitor the statistical characteristics of the process to determine if the process is in control and if it's statistically capable. Normally for this index we talk about CPK, and within AS9145 then we tend to have any CPK better than 1.33 is considered acceptable. The culmination of the production process run, and that is that we will take a product from this production process run and we're going to inspect it against the original product definition. There's a number of protocols for doing this, but typically it's done using AS9102, which defines a set number of pro forma documents for data to be entered during the product inspection and performance testing. Again, we need to refer back to the customer, because typically a fair pack incorporates documents over and above the standard templates. So again, we need to be talking to the customer and asking the customer what is required in support of the fair. As far as AS9145 goes then, when we think about PPAP, what we need in the PPAP file then is evidence of a conforming fair. And again, the extent of this evidence is going to be defined between the supplier and customer. It could be as simple as the front page of the fair pack, or it could be all of the fair template documents, or it could be any additional requirements that the customer requires. Talking about customer specific requirements then, what we can see here on the left-hand column then is the 11 elements of PPAP required by AS9145. In the middle, we can see Rolls-Royce's supplier requirements, and what we can see there then is that we have the 11 AS9145 requirements, but then another 10 requirements. So a PPAP for Rolls-Royce would incorporate 21 elements. And then on the right-hand side, we see the PPAP requirements for UTC. Again, we can see the 11 AS9145 requirements, and we can also see that UTC have additional requirements. So part of successful APQP and PPAP is having a good understanding of the customer's specific requirements over and above achieving the requirements of AS9145. If we look at the APQP process then, what we can see here is that I have overlaid the 11 PPAP elements, and going back to one of the earlier themes, it's quite clear then that if we follow the APQP process, by the time we get to the end of the process, we will have created all 11 PPAP elements. So let's think about this. If we do APQP, we can get PPAP free. So as we have seen, if we follow the APQP process, all of the elements of a PPAP file will have been created. More importantly, we will have done the right things at the right time with the right people for the right reason. And by doing this, we get the true benefits. The alternative is to create the documents to tick boxes. In this case, we're going to have all of the costs and none of the benefits. The reality of this situation is that it's not assuring the customer of the quality of the product. It's not assuring the customer of the ability to achieve right first time and rate requirements. All it's done is added costs to the supply organisation and inconvenience to the customer, when in actual fact you can't deliver the right quality at the right rate. If we think about PPAP then, which is the last action from step 4 of APQP, then again we're going back to the automotive industry, and again we're going back to our friends at the IAQG. So Ford, GM, and at the time Chrysler created another blue book, which was the blue book covering PPAP. And so if we think about the blue book family, we have APQP, FMEA, SPC, MSA, and PPAP. And these are all concepts that we've seen rolled up into AS9145 and PPAP. So thinking about the purpose of PPAP, it will determine if all of the customer engineering design record and specification requirements are properly understood by the organisation, that the manufacturing process has the potential to produce product consistently, that we can meet all of the customer's requirements during an actual production run, and that the PPAP file can also be used as the prime source of evidence during audit to demonstrate that an APQP approach was followed. And when we think about auditing, this could be a third-party certification body making the audit, it could be a customer audit, or it could be, in fact, the organization's own internal audit. So how would we go about this then? Well, we would identify the applicable PPAP elements, including customer-specific requirements. We would gather the applicable data to create a PPAP file for the products requiring PPAP. And the key word here is gather, because if we followed APQP, all of the information should be available. It's just a matter of collating it into the PPAP file. We need to comply with PPAP submission requirements in accordance with the organisation and customer requirements. We need to maintain the PPAP file and ensure accessibility as required. Now, this accessibility again could be from the organisation's own project team, it could be from the customer's project team, and once again it could be third-party certification bodies. We need to notify the customer of any product or process changes determined and the requirements for approval. And then when the PPAP submission requirements are not fulfilled at the time of the submission, the organisation shall provide a plan for resolution of all of the associated requirements. So if we think about the ideal situation, then we've defined the PPAP elements. They are all included in the PPAP file, and then the organisation shall submit the specified contents of the file to the customer or the internal organisation. So hopefully all is good and we get PPAP signed off. Or if the PPAP requirements have not been completely fulfilled, then the organisation may still proceed with the submission. However, that submission is going to be made with known deficiencies, and we need to supply some form of corrective action plan to bridge the gap between the file originated and the deficiencies that need to be resolved prior to final sign-off. So the organisation shall indicate an incomplete submission on the PPAP approval form and provide the plan for resubmission to establish full approval. If we think about the product approval form, then it's a straightforward document that encapsulates the reason for the submission, the documents that have been submitted, and then finally the customer's disposition with any comments or instructions that are associated. Thinking about customer disposition then, we have three possibilities. The first possibility is that the PPAP file, the product and the supporting data are all acceptable. So this indicates that all of the PPAP requirements have been met. The organisation is therefore authorised to ship product. We could have an interim approval, and in this instance there could be problems with the PPAP documentation itself, or there could be some problems with the product achieving the full specification. However, the customer is able to give a concession so that the product can be used. And so an interim approval indicates that all PPAP requirements have not been met. However, the organisation is authorised to ship product under conditions or restrictions specified by the customer. And quite often these restrictions or limitations are things like a set number of parts or a set period of time during which the expectation is that any issues will have been resolved and that the supply organisation will have resubmitted PPAP and gained full approval. In the worst situation, then we could have rejected. This typically means that the product supplied does not meet specification and that the customer is not able to issue a concession to accept the goods. So rejected indicates that the PPAP requirements have not been met and that the organisation is not authorised to ship product. If we think about PPAP records, well, it's a quality record. It should be maintained within our quality management system. And so records of PPAP should be maintained in line with customer specific requirements. So again, we're going back to the customer and asking the question, what are your requirements for the retention of PPAP records? And also we need to think about regulation. So there may be regulatory powers of force here which dictate the length that the records are retained. If we have a situation where we either have submitted a PPAP and it was not accepted, in which case we have some discrepancies, or if there's a change to the product after PPAP, then we will make a PPAP resubmission. And so the organisation shall apply the applicable APQP activities and comply with internal and customer requirements regarding the PPAP submission. One final thought, the process of APQP does not conclude at PPAP. We still need to make provision to cover our contractual obligations respect to the ongoing supply of product and after-sales activities. So we move into step 5 of APQP, which is the ongoing production, use and post-delivery service. And the goal of this phase is to ensure that customer requirements are continually fulfilled through the use of process control, lessons learned and continuous improvement. So two things really happening at this point then. We have project closure and then we go into project maintenance where we are monitoring our quality, cost and delivery performance as an ongoing basis to our customer. So with that, it concludes the main section of this. However, for further information and our training activities for AS9145, then I'd like to make you aware of the 5-day practitioner course, which covers all of the fundamentals of AS9145, plus a quite in-depth review of FMEA, SPC, MSA, control plans at a practitioner level, and then the shorter 2-day AS9145 Essentials, which takes a more in-depth view of the requirements of AS9145 and the leakages again into the other core tools. So with that, I'd like to thank you for your time and I'd like to bid you goodbye.